Welcome back. So today we're going to talk about another type of geometric series. We're going to talk about an infinite series. So by infinite series, what I mean is that there is no end to it. It goes on forever. Now, it diverges. Now, what diverges means is if the rate is greater than 1. So what I mean is if you have an r of 2, an r of -3, an r of 4, all those are going to diverge because the terms are going to be getting bigger and bigger and bigger. They're not going to be settling in on a particular value. Converge. That means if you have a half, -1/3, 3/4. Those because now the terms are going to be getting smaller and smaller. You're multiplying by a decimal. Therefore, they're going to hone in on a value. Every term will be getting closer to 0. So as a whole, the sum will be converging to a particular number. To show you what I mean by that, let's just take an example here. So if I go and I add my first two terms here, I get 3. Add in the 4 to get 7. If I add in the 8, I get 15. I add in the 16, I get 31. I add in the 32, that gives me 63. So on and so forth. So notice, as I'm adding up all my terms, my sum is getting bigger and bigger because each individual term is getting bigger and bigger. Now what I want you to notice, the difference between that and a convergent series. When you have a rate that is a fraction, so your terms are getting smaller, look at what happens, what that difference is. So notice there, I get 1.5. When I add in the 0.25, now the sum is 1.75. I add in the 0.125, now my sum is 1.875. Now I add in the 0.0625, and I get 1.9375. If I add in the 0.03125, get 1.9685. If I add in the 0.015625, now I have 1.984375. So if you notice, because each individual term is getting closer and closer to 0, our sum here is stabilizing. Our sum is getting closer and closer to 2. All right, so I want you to pay careful attention to that. Okay, convergent. When your terms are getting smaller and smaller and smaller, that means you're multiplying by a decimal. When that happens, your sum is going to be convergent. All right? So let's take a look at how we actually calculate that. So the nice thing is our formula for this is actually easier than the formula you were using for normal geometric series. So once you've identified that it is convergent, then you use this formula to calculate it. So let's take a look here. 20, 15, 15.75, 11.8125. And I actually do believe that there is a typo in there. So if you could please change these, this should be an 11.25 and an 8.4375. So if you could change those for me, please, you'll be able to see that the terms are in fact getting smaller. They're converging. The reason they're converging is because my R value, if you take 15 divided by 20, my R is 0.75. My R is a fraction, therefore it is going to be a convergent series. So once I've identified that yes, it is convergent, once I identify that, now I can actually find the sum. And the sum is going to be that first term divided by 1 minus the R value. So 1 minus 0.75. Right, and again, you always want to calculate that bottom first. Well, 1 minus 0.75 is 0.25. So 20 divided by 0.25 is going to leave you with 80. That sum, no matter how many terms you go out to, the sum is going to be approaching the value 80. All right, what about this next one? Well, notice these numbers: 1, 1.5, 2.25, 3.375. Well, notice those are getting bigger. So because those are getting bigger, that makes this a divergent series. And when the series diverges, it means that there's no sum. Because the terms are getting bigger and bigger and bigger, they're not settling in on a particular value for a sum. So there's nothing more we can do when that's the case. But let's take a look at this one. 4, negative 0.5, 6.25, negative 7.8125. So again, I want you to note that ignoring the sign, aren't the terms getting bigger with every term? So again, because the terms are getting bigger, that is going to make this once again a divergent geometric series. They're not honing in on a particular value. So because of that, we can just say that there's no sum and be finished. All right, so let's take a look at this next one. So here, 10, negative 2, 0.4, negative 0.08. Those terms are getting smaller. So this is looking quite promising, okay? This is what we really, really need. This is going to be convergent. And to find what the actual R is, negative 2 divided by 10 is actually going to be negative 0.2 for our R value, the rate that we're multiplying by. Once we have that R, now we can plug it into that formula. So the first term divided by 1 minus that R, so we get 10 divided by 1.2. Because remember, subtracting a negative is the same as adding. So 10 divided by 1.2 is 8.3 repeating. So that's what I'm talking about, where yes, you could write it as 8.3 repeating, but notice it's a decimal that doesn't have an end. So another neat thing you can do is actually ask your calculator to turn it back into a fraction for you. In order to turn it back into a fraction, all you have to do is go into Math, click on Arrow Fraction, hit Enter one more time, and it'll actually do it for you. That is going to be 25 thirds. So that's a neat little trick so you can keep your answers exact. So make sure you remember that. If you ever have one that gives you a repeating decimal, just do that and it'll turn it back into a fraction for you so you can keep it as exact as possible. All right, so thank you for joining me for this video. Again, make sure you ask any questions if you have any questions before you turn in before you come and see me for your practice work.